Today we are solving systems by elimination day number 3. Our content objective is students will be able to solve systems of equations by, of course, elimination. Language objective is students will be able to explain how to eliminate a term to solve for a variable. And last but not least, why am I learning this? Well, it's important for real life problems like how many of each shirt or pants you can purchase with a specified budget. So first, let's go over some background knowledge. We've used elimination for a while now. In this case, our goal is to make sure we can at least eliminate one variable. So in this case, if I change the second equation by multiply by -2, I'll be able to eliminate the x's. So this property is the multiplication property of equality. That's what's allowing us to manipulate the equation by still keeping its equivalency. So here, the first one's going to stay exactly the same. However, the second equation, since we're multiplying the entire thing by -2, will become -2x. Here, -2 times -4 is positive 8y. -2 times positive 9 is -18. Now we have we have a new equation, so we're going to go ahead and eliminate the x's, leaving us with 11y equals -22. Divide both sides by 11 and y equals -2. But we're not done. We need to plug that into one of the original equations. I'm going to go ahead and plug it into the second one because it seems a little bit more simple. Plugging it in for y. Now we have x plus 8 equals 9. Subtract 8 from both sides and x equals 1. So here I would say that I think the solution is 1, -2, but you wouldn't say you know until you, of course, have checked your answer. Okay, so let me show you how we would do a problem like this, because hopefully you noticed as the days went by when we're solving elimination, it got a little bit more complex every single day. So here, I'm going to take a look. I'm going to check to see, is it going to be better to eliminate the x's or to eliminate the y's. So here, what I first look at is, okay, looking at the x's, I'm going to find the lowest common multiple. And the lowest common multiple between 2 and 5 would be 10, which means I would have to multiply this by a 5 and multiply this by a 2, since one's already positive, one's already negative. And here, between the y's, what's the lowest common multiple between 2 and 3? I would say 6. Therefore, since one's already positive, one's already negative, I would have to multiply the first one by 2 to make it a 6, and multiply the second one by 3 to make it a 6 as well. So just because I think it'd be easier to multiply the entire equation by smaller numbers, I'm actually going to go ahead and multiply to get rid of the y's. So let's go ahead and try that out. We're going to put in our parentheses. So in this case, if I want to eliminate the y's, since one's already positive, the other one's negative, I just need to multiply it by the number. And the lowest common multiple is 6, so 3 needs to be multiplied by 2, which is going to leave me with a -4x, because 2 times -2 is -4. 2 times a 3y is a positive 6y. 2 times a 5 is a positive 10. So now looking at the next one, what am I going to have to do here? Well, again, if I'm wanting to eliminate the y's, I need to multiply this second equation by a 3, since I'm going for the lowest common multiple of 6. 3 times 5x is going to become a 15x. 3 times -2y would be -6y, which looks good because it will eliminate these. And then 3 times 4, which is a 12. Now here you will see the y's will definitely cancel each other out, leaving me with 11x equals 22. Divide both sides by 11, and I'm left with x equals 2. However, we know we're not finished yet. We're going to have to plug it into one of the original problems. I'm going to go ahead and plug it into the first one, -2x plus 3y equals 5. What I'm going to do is go ahead and take this x and plug it into my equation just for the x, which leaves me with -2 times 2 plus 3y equals 5. So here we have -4 plus 3y equals 5. We can add 4 to both sides, leaving me with 3y equals 9. Almost done. Dividing both sides by 3, I'm left with y equals 3. So here I would say that I think the solution is 2 comma 3, but you know I will always say think because we still need to, of course, check our work. Okay, so now what I want you to understand was that was one option. There's another option. Okay, instead of eliminating the x's, instead of eliminating the y's, I had a different option. I could have, if I wanted to, eliminate the x's. So let's check. If we eliminate the x's instead, would we still get the solution of 2 comma 3? Well, let's see. So here, if I wanted to eliminate the x's, I would say the lowest common multiple between a 2 and a 5 is 10. So this equation here would have to be multiplied by a 5. Notice I'm not changing the signs at all because I already have a negative and I have a positive. So that's taken care of. So let's go ahead and change this to a negative 10x and positive 15y equals a positive 25. Now here, again, we're still rooting for the lowest common multiple of 10. So I need to multiply this 5x by a 2. So this is going to give me a positive 10x. 2 times negative 2y is a negative 4y. 2 times 4 is 8. So this is going to cancel each other out, which is exactly what I needed, leaving me with just 11y equals 33. So I'm going to divide both sides by 11, and I'm left with y equals 3. So that's exactly what we had for the last one. Y was 3. Now let's go ahead and plug it back into one of the originals. Let's pick the first one. Negative 2x plus 3y equals 5. I'm going to go ahead and take the value of y and substitute it in for y in the new equation, which is going to leave me with negative 2x plus 3 times 3 equals 5. Now we have negative 2x plus 9 equals 5. Get rid of the constant, leaving us with negative 2x equals negative 4. Let's get rid of our coefficient, and we're left with x equals a positive 2. So look here, notice the solution is still 2 comma 3. So it doesn't really matter which variable you choose to eliminate, you're still going to get the same solution. Because in a system, there's only, so far since we've learned, there's one solution. Okay, later we'll get into having no solution or infinitely many, but for right now, those are the options. And of course, if you checked it, it will show you that it does work. So at this point, I am going to stop showing you the work of how to check it because I'm hoping that you've got the idea now. And if you need a refresher, please refer to the previous lessons where I did show the checking of the work to confirm that it was a solution to the system. Okay, so now at this point, let's go ahead and try one together. So for this one here, if I wanted to eliminate the x's, I would say the lowest common multiple between a 6 and a 10, it's actually 30. I know a lot of my students, what they think in their head is, oh, all you need to do is multiply them together. Well, if you multiply them together, guaranteed it is a common multiple, but it's not going to be the lowest one. And if I were you, I want to keep it as low as possible. That way, if I were to change any of the equations, it wouldn't be by a large coefficient. I'm trying, well, not guaranteed large, but you want to keep it as low as possible. So just a quick reminder, please don't automatically just assume that by multiplying them together, that's the lowest common multiple. So here, I would have to multiply the first equation by 5 to make the 6 a 30. And I would have to multiply the second equation by 3 to make the 10x a 30. Now, if I wanted to, I could also eliminate the y's. The lowest common multiple between a 2 and a 7 is a 14. So that means I would have to change the first equation by a 7 to make the 2y 14. And I would have to make the second equation, multiply the second equation by 2 to make the 7y 14. I think it's going to be best if I eliminate the x's, so that's just a choice. Would it be wrong if you wanted to eliminate the y's instead? Absolutely not. But I'm going to go ahead and show you how I would eliminate the x's. So I'm going to have to change both because the lowest common multiple is 30. So this one here, because it's a 6x, I'm going to have to multiply it by 5. I do notice that they're both the same sign. So I'm definitely gonna have to multiply one of them by a negative. So I'm just gonna go ahead and choose this one to be the negative. So this is going to change to a negative 30x minus 10y equals a negative 20. Now, what do I have to do to the second equation? Again, I still want the multiple to be 30. So here, I'm going to have to multiply the 10x by a 3 to make it a 30. So here we have a 30x. It's perfect. There's one that's negative, one's positive, so those will eliminate. That's exactly what I need. Then I'll have plus 21y equals a negative 24. So here, you'll see that the x's cancel out, leaving me with just 11y equals negative 44. Divide both sides by 11, and y equals negative 4. Of course, we're not done. We're going to have to plug that into one of the originals. I'm going to choose the first one just because it seems a little bit more simple. 6x plus 2y equals 4. Now I'm going to go ahead and take this value for y and substitute it in just for y, leaving me with the 6x plus 2 times negative 4 equals 4. Now we have 6x minus 8 equals 4. Simply get rid of the constant by adding 8 to both sides. So we have 6x equals 12. Almost done. Divide both sides by 6. And I'm left with x equals 2. So I'm going to say that I think the solution is 2, negative 4. Quick reminder, x is always written first, y is written second. You know that I always say think at first because you need to, of course, check your work. And again, I'm not going to be showing the check in this particular video. If you do need a reference, please refer to some previous lessons. I will go ahead and provide a link in the description box if you would like to see a previous lesson where I'm showing the work of the checking. Okay, so now what I would like you to do is go ahead and pause the video and try number 3 on your own and see how well you do. Okay, so let's see. So options are definitely going to vary. You can either choose to eliminate the x's or you can eliminate the y's. Well, here the lowest common multiple between a 2 and a 3 is 6. So in order to make this 2x is 6, I'm going to have to multiply the first equation by 3. And in order to change this negative 3x is 6, well, not negative. This 2 is 6, I'm going to have to multiply by 2. So that's one of my options, multiply by 2, multiply by 3. Now let's look at the other option. Here, between 6 and 4, the lowest common multiple is a 12. So I'm going to have to multiply this one by 2 and this one by 3. So guess what? It really didn't matter which one you chose. You're still about the same difficulty level. So let's go ahead and try it out. So here, let's go ahead and just eliminate the y's, just because since the last one we eliminated the x's. We said that it's going to be, we're trying to get the lowest common multiple of a 12. So I'm going to go ahead and have to multiply the 6y by a positive 2. So notice here, one is positive, one is negative, so I'm not going to have to multiply by a negative coefficient because that's taken care of. So now this is going to change to a 4x plus 12y equals a negative 12. Now the second one, since we're trying to eliminate the y's, I need to make it this negative 4y into a negative 12y. So I have to multiply by 3. So it's going to give me a negative 9x minus 12y equals negative 18. Here we have a negative 5x, the y's cancel out, equals negative 30. Divide both sides by a negative 5. The negatives cancel each other out, leaving me with just x equals 6. Of course, we're not done. We're going to have to plug it back into one of the original equations. So I'm going to go ahead and put 2x plus 6y equals negative 6. We're going to go ahead and take this value and substitute it in just for x. So that leaves me with 2 times 6 plus 6y equals negative 6. 12 plus 6y equals negative 6. Subtract 12 from both sides. 6y equals negative 18. So divide both sides by 6. And I'm left with y equals negative 3. So here, the solution is 6 comma negative 3. Friendly reminder, x is written first, y is written second. Of course, I would say here that I think the solution is 6 comma negative 3 because I would still have to check my work. Okay. Again, I'm not going to be checking the work in this particular lesson, but please refer to another video if you need help on how to check work. Okay, so I'm going to go ahead and show you one more, and then I'll have you try the next one on your own. So here, let's see, if I wanted to eliminate the x's, the lowest common multiple between a 3 and a 5 is 15. So I'd have to multiply 1 by a 5 and 1 by a 3. Since they're both the same sign, I would have to multiply one of them by a negative. It really doesn't matter which one you choose. Let's just make the negative 3 negative. So that's one option. Let's look at the other options. If I wanted to get rid of the y's, the lowest common multiple between a 4 and a 5 is 20. So here I have to multiply the first one by a 5 and the second one by a 4. And again, since both of these are the same sign, I'm going to have to multiply one of them by a negative. And it really doesn't matter, but I'll go ahead and pick the smaller number to be a negative. Okay, so here, does it really matter which one you choose to eliminate? Not really, but I just want you to see the options. If it was up to me, I would choose to eliminate the x's just because the coefficients are smaller. So let's go ahead and do that. So for the x's, I'm going to go ahead and use the lowest common multiple of 15. I'm going to multiply the first one by a 5, which is going to change this to a 15x plus 20y equals 20. Now for the second equation to eliminate the x's, since we already have a positive 15x, I'm going to have to go with a negative since this is already positive. And the lowest common multiple is 15, so 5 is going to be multiplied by 3, leaving me with negative 15x minus 15y equals 0. So here, the reason why I wanted to make the smaller number negative is so I can keep, there's a greater chance that I will be left with a positive coefficient for the other variable. And I always want to keep it positive. So here the x's cancel each other out, leaving me with 5y equals 20. Divide both sides by 5, and I'm left with y equals 4. But of course, we're not done yet. I'm going to go ahead and choose the second one to use because I like working with the number 0. So 5x plus 5y equals 0. We're going to go ahead and take this y and substitute it in just for the y, nothing else. So we have 5x plus 5 times 4 equals 0. Here we have 5x plus 20 equals 0. Subtract 20 from both sides. I'm left with 5x equals negative 20. Divide off that coefficient. And I'm left with x equals negative 4. Here, I think the solution is negative 4 comma 4. But again, I would say think until I've checked my work, and then I would say that I know. So now it's going to be your turn. You're going to go ahead and try number 5 on your own. Okay, so let's see how well you did. So here, let's just take a look at our options. If I wanted to eliminate the x's, I'm going to say the lowest common multiple between a 6 and a 4 is a 12. So here, I'm going to have to multiply this first equation by 2, because 2 times 6 is going to give me 12. I'm going to have to multiply the second equation by a 3, because 3 times 4 is 12. And again, since these are both positives, I'm going to have to make one of them negative. So I'd make the 2 a negative just because I want to keep the smaller number negative. Now let's look at our options for y's. So here, I would say the lowest common multiple between 6 and a 5 is 30. So what I would do is go ahead and multiply the 6 by 5 to make it a 30. And I would multiply the 5y by a 6 to make it 30. And I would keep the negative on the smaller number. So here are the options. I can eliminate the x's, or eliminate the y's. Hopefully you think about it and think to yourself, it might be better to eliminate the x's just because the numbers are smaller, and when the numbers are smaller, you tend to make less mistakes, but that's just something to keep in mind. Okay, so let's go ahead and eliminate the x's. Here, we're going to multiply this first one by a -2 like planned. And real quick, again, if you chose to eliminate the y's, are you still going to get the same answer? Absolutely. It really doesn't matter. It's whatever you see first and whatever comes easiest to you. So here it's going to change to a -12x minus 12y equals -12 times -6 is going to be a +12. Next, again, we're trying to get it to be a lowest common multiple of 12. So here, since it's -12, I'm going to make the next one a +12. Since there's already a 4x, I'm going to multiply it by a 3, which is going to give me a +12x plus 15y equals a -21. Now here, the x's will cancel each other out, leaving me with 3y equals -9. Simply divide both sides by 3, and I'm left with y equals -3. Now I'm going to go ahead and plug it into one of the originals. I'm going to go with the second one, 4x plus 5y equals -7. What I'm going to do is go ahead and take this value for y and simply substitute it in only for y. I keep stressing this because sometimes students will plug it in for 5y instead of just y by itself. So here we have 4x plus 5 times a -3 equals -7. We have 4x minus 15 equals -7. Simply add 15 to both sides. And I'm left with 4x equals, oops, forgot to put 15 there, equals 8. Divide both sides by a 4. And I'm left with x equals 2. So here I'm going to say that I think the solution is 2, -3. And I would say think because, again, I want to make sure by, of course, checking my work. So that is going to almost conclude our lesson. We're just going to go ahead and do a quick summary of what we've done so far with solving systems. The instruction says here to fill in the blank to complete our lesson's conclusion statement. I have been taught blank types of methods to solving systems. So how many have we learned? Well, the first one was graphing. The second one was substitution, and we've been currently working on elimination, so that's going to be a total of 3. The first method is by, which I just mentioned, graphing. I can determine the solution by looking to see where the lines, what do you think? Hopefully you said intersect or touch, something along those lines. The second method is by substitution, where my goal is to first isolate, which means just to get the variable by itself. Isolate one of the variables in one of the equations and substitute it into the other equation. The third method is the elimination method, where my goal is to eliminate one of the variables to solve for the other variable. So hopefully you remember that there's more than just one method. I know we're currently working on elimination, but we've learned how to use substitution to solve for systems as well as graphing. So that's going to conclude our lesson for today. Thank you so much for tuning in, and as always, until next time, bye.